Good morning, students. आप लोग कैसे हो? I hope you all are fine. Today we are going to discuss redox reaction. Got it? We are going to discuss. This is the redox. Once you see that, redox is made up of two words. The redox आप देख सकते हो red and ox. Got it? Redox. Oh, we can write it like red and ox. This is red and ox. Red means it's going to be red means red color. Got it? Lol. Ox means like bell. No, no, no. Got it? It's not a red ox. Got it? Here the red means reduction. Red means reduction, whereas ox is ox means over oxidation. Yeah, red means reduction, whereas ox is oxidation. Now we can see here, uh, let us see some example, we are having battery. There is some reaction, there is a positive terminal and there is a negative terminal. Inside this battery, there is a redox reaction. Battery produces the current because of redox reaction. यहाँ पे आप देख सकते हो there is a combustion. At the time of combustion, your gas or LPG gas is going to burn with the air. With the air, that is the oxygen gas. And after that, there is a formation of carbon dioxide, then H2O. Both are in gaseous state, along with heat. Rusting of iron. That is also the example of redox reaction. Iron is going to chemically combine with water and air. Upper surface of iron is going to reddish brown in color and its formula is going to be Fe2O3.XS2. Rusting of iron is example of, rusting of example is example of your rusting of iron is example of redox reaction. Refining of impure metal. We can do refining of impure metal into pure metal by using redox reaction. Now, we are going to discuss definition of redox reaction. What the classical concept? There is a two main definition. One is a classical and there is a electronic concept. Electronic concept, oxidation and reduction and oxidation number. Now, classical and electronic concept of redox reaction. This is the classical and electronic concept. We are going to discuss one by one. We will discuss both the case. I have already explained this. Redox is reduction and ox means oxidation. The reaction in which oxidation as well as reduction both occur simultaneously, that is called redox reaction. The reaction in which oxidation as well as reduction both occur simultaneously, so that is called redox reaction. This is the definition of redox reaction. A reaction in which oxidation as well as reduction both occur simultaneously. ये हमारी पहली definition होगी for oxidation. During the oxidation, addition of oxygen or maybe more electronegative element takes place. Take example, there is a magnesium metal going to chemically combine with oxygen to form magnesium oxide. Sulfur is going to chemically combine with oxygen to form sulfur dioxide. Magnesium going to chemically combine with fluorine to form magnesium chloride. These all are example of oxidation. These all are the example of oxidation. So when magnesium chemically combined with fluorine, there is a formation of MgF2, where fluorine is MENA, more electronegative element. Fluorine is more electronegative atom and magnesium is a metal. So when a particular element combined with more electronegative element, always there is a chances of oxidation because magnesium is going in +2 and fluorine is going in -1. Now take the example of uh, same oxidation with the in the term of hydrogen gas, in term of electropositive metal. So there, if you see in case of CH4 carbon, methane is having 4 hydrogen atom. Right hand side carbon is not going to be the hydrogen atom. If you compare carbon to carbon, hydrogen is going to loss and oxygen is going to add. Loss of hydrogen is again kind of oxidation. Loss of hydrogen is kind of oxidation. H2S sulfur is V with the here hydrogen atom. Right hand side sulfur आपका separate है, there is no hydrogen atom. So moving from H2S to S is a kind of oxidation, removal of hydrogen. See this case, potassium ferrocyanide plus hydrogen peroxide. Right hand side we are having, yeah, earlier यहाँ 4 potassium था, now there is only 3 potassium. So more reactive metal is going to be lost or going to be reduced, less in number. So that is also the reference of oxidation. Finally, we can have a conclusion. Very simple. Positive means addition of oxygen atom is oxidation. Positive means addition of MENA, more electronegative element. You must remember the order of more electronegative element. FONCLBRI, FONCLBRI, then carbon, then hydrogen atom. So one more electronegative atom is going to combine, then it is called oxidation. For example, we are having carbon going to react with chlorine. There is a formation of CCl4. Chlorine is going to be MENA. Chlorine is more electronegative element going to combine with carbon. So there will be oxidation of carbon takes place. This is a case of oxidation. Now, see the definition of reduction. Removal of oxygen or maybe more electronegative element. Both is the example of reduction. Addition of hydrogen or any metal or electropositive element, that is called reduction. In this case, you can see that mercury oxide is going to be heat. Mercury oxide is going to be heat, and there is a formation of magnesium and oxygen. Moving from mercury oxide to pure mercury, there is loss of oxygen. There is loss of oxygen. Loss of oxygen is taken as reduction. Loss of oxygen is, that is called reduction. Loss of of oxygen is going to be reduction. In this case, addition of hydrogen, this is your ethene gas going to chemically combine with the hydrogen gas. There is a formation of ethane. Left hand side number of hydrogen are less, right hand side number of hydrogen are more. Addition of hydrogen is going to take place. This is the addition of hydrogen. Addition of hydrogen gas is example of reduction reaction. That is the example of reduction reaction. So reduction is vice versa of, opposite to that, oxidation. Now we are going to take the example of, we are going to discuss that electronic concept of redox reaction. When we talk of the electronic concept, we are going to take the reference of electron. Let us take the example of formation of sodium chloride. Configuration of sodium is 2, 8, 1, whereas configuration of electronic configuration of chlorine is 2, 8, and 7. There is a combination. Sodium will lose one electron and it will give to chlorine. So there is a loss of electron from sodium, and chlorine is going to gain electron. Chlorine is going to gain of electron. Gain of electron is called reduction. Very simple, you can simply write LeOGer. LeOGer. Loss of electron is oxidation. Gain of electron is reduction. Loss of electron is oxidation. Gain of electron is reduction. Loss of electron is oxidation. This is the loss of electron. Whereas chlorine is going to gain the electron. So in this case, moving from this, there is a sodium to sodium chloride. We are having sodium, we are having chlorine. Right hand side, there is a formation of NaCl. Sodium is going in sodium plus 1. Chlorine is going from 0 to -1. So there is a oxidation of sodium. This is the oxidation. Whereas moving from chlorine to chloride, and that is the example of reduction. That is the example of reduction. Now we can check that oxidation number concept or maybe loss of electron. If you see the Rn is having here +2, right hand side Rn is having going to be +3. There is a loss of one electron. The loss of electron is taken as oxidation. Increase in oxidation state. Increase in oxidation state. +2 to +3. Higher minus lower, find out करना 3 - 2 is equal to +1. Increase in oxidation number is also known as oxidation. Decrease in oxidation number charge. Yeah, see that -1 left hand side, right hand side chlorine having no charge means zero. Final minus initial, that is going to be +1. Increase in oxidation number. Increase in oxidation number. When we talk beta increase की बात करेंगे तो +2 to +3 can be happen. -2 to 0 can be happen. Increase in oxidation number is known as oxidation. Known as oxidation. Now, this is the again same definition we have discussed earlier. Decrease in the positive charge. Decrease in the positive charge is the example of reduction. Decrease in positive charge. We are having suppose Rn +2 or maybe +3 और इसको एक इलेक्ट्रॉन हम गिफ्ट हैम्पर देते हैं. There is a this +1 and -1 is going to cancel. I can get here Rn +2. Moving from Rn +3 to +3, there is a decrease in oxidation number. Decrease in oxidation number. That is the example of reduction. That is the example of reduction. Finally, this is the conclusion of that. Loss of electron is oxidation, gain of electron reduction. Let there is a reaction takes place, between zinc and copper. Zinc is going to do the reaction with copper sulfate. And we know that what will happen? There is formation of ZnSO4 along with there is a copper, metallic copper. Zinc is moving from zinc to ZnSO4 going in +2 and copper is moving from +2 to 0. Copper is undergoing reduction. This is the case of reduction and moving from Zn to Zn+2, that is the case of oxidation. So during the oxidation, charge always increases. Transfer of electron takes place. The more reactive metal displaces less reactive metal from its salt solution. These are the example of redox reaction. Final summary you can check here. This is the final summary. Addition of oxygen or more electronegative element is oxidation, whereas removal of oxygen or more electronegative element is called reduction. Removal of hydrogen is a case of oxidation. Addition of hydrogen or maybe metal or more electropositive element is called reduction. Loss of electron is oxidation. Gain of electron is always going to be reduction. Gain of electron is going to be reduction. Now we are going to discuss the very important topic that is called oxidation number. Oxidation number. What is the oxidation number? Suppose I am going to write here sodium is having +1. So I will say its oxidation number is how much? Oxidation number is +1. And what about the valency? Valency is going to be 1 only. Valency is always shown in the neither in plus, neither minus, simply whole number. But oxidation number can be +1, can be -1, can be even a Roman number. What is the oxidation number? This is the apparent charge on any atom. Let there is a bond is formed between hydrogen and fluorine. We know that fluorine is mean. Fluorine is going to be more electronegative. फ्लोरीन अपने इलेक्ट्रॉन को तो यहाँ पे पुल करेगी बट एट द सेम टाइम हाइड्रोजन इलेक्ट्रॉन आल्सो काउंटेड in the side of more electronegative element, so that fluorine will carry -1 and hydrogen is going to carry +1. Hydrogen is going to carry +1. Got it? Now, see that, always we count the electron towards more electronegative element, towards more electronegative element. If the both the atom are identical, both the atom is identical, having same electronegativity, in that case, electron will be distributed equally. No loss, no gain, no charge. No loss of electron, no loss of electron, no charge. It means its oxidation number is taken as 0. See all the example here, maybe hydrogen molecule, maybe, hydrogen, maybe oxygen gas. All these gas, all the atom are identical, so that finally their oxidation state is going to taken as zero. The element in their free state, when they are not combined, always be a zero oxidation state. When we talk about element, it can be either metal, it can be either non-metal, metal, maybe non-metal, maybe metalloids, maybe metalloids. All are going to be zero oxidation state, maybe magnesium, maybe aluminum, maybe sodium. Why there is zero oxidation state? Because number of electron in atom, number of electron and proton are going to be same. As many plus, that many minus, plus minus, that is going to be balance. That is why there is no charge. How we can calculate oxidation number in the given compound? Suppose we are having NaCl. Na is having plus 1. Let we don't know about the chlorine, we can consider X. यहाँ पे आप इसकी एटॉमिसिटी चेक कर लेना 1. This is the atomicity 1. To calculate, earlier NaCl having no charge, net charge is 0. Plus 1 plus X is equal to 0. X will be equal to minus 1. Take any other example. Suppose we are having calcium chloride. In this case, let me remember the valency of calcium plus 2. Chlorine, we don't know X. So now we can calculate 1 into plus 2 plus number of chlorine is 2. 2 into charge on the chlorine considered as X is equal to 0. Plus 2 plus 2x is equal to 0. 2x is equal to minus 2. Now rearrange it. 2x is equal to minus 2. X is equal to minus 1. That is the oxidation number of each chlorine atom is minus 1. Your few facts are there, you can remember it. One is your alkali metals. All alkali metal always having, plus 1. Helena career सबसे फरियाद means lithium, maybe sodium, maybe potassium, maybe rubidium, maybe cesium, maybe francium. All are having always plus 1 oxidation state. What about the plus 2? Beta mange car, scooter bapraji. Beta mange car, scooter bapraji. But in all cases, common valence C, common charge, common valence is 2, and charge is always considered as plus 2. All these element, when we talk about the aluminum, it's always going to plus 3. What about the oxygen? Oxygen can exist in the form of oxide. In the form of oxide, it is going to be minus 2. In the form of peroxide, oxygen is having minus 1. In case of superoxide, it is having minus 1 by 2. Oxide, peroxide, and superoxide. Here you can take the example. Suppose I am having calcium oxide CaO. Calcium having plus 2, तो यहाँ पे क्या आना चाहिए minus 2, so that resultant should be 0. I'm talking about the peroxide, hydrogen peroxide, HO, then H. Beta mathematically we are going to calculate, it is having plus 1, it is having plus 1 hydrogen. और ऑक्सीजन का हमें क्या कंसिडर करना है, X and X. तो नंबर ऑफ टोटल पॉजिटिव चार्ज सम करो, +1 +1 +2 plus 2x is equal to 0. So now 2x can be written as minus 2, so x is equal to minus 1. Each oxygen are having minus 1. Each oxygen is having minus 1. How we can check electronically? Let we are having H, O, then H. Now see that terminal bond is between hydrogen and oxygen, where hydrogen is more less electronegative, oxygen is more electronegative. Now in this case, both the electron will be counted only towards the oxygen. So oxygen will carry minus 1, hydrogen will carry plus 1. Got it? Go in the left hand side. This is the hydrogen and oxygen again. Both the electron counted in towards the more electronegative element. That is why oxygen will carry minus 1, hydrogen will carry plus 1. But the electron present between oxygen and oxygen, they are having same electronegativity. So electron will be distributed equally. मीन्स अगर आपने बिजनेस पार्टनरशिप अपने फ्रेंड्स के साथ अपने घर में किया है तो देर इज नो लॉस नो गेन, इलेक्ट्रॉन विल बी डिस्ट्रीब्यूटेड इक्वली. If there is identical atom, electron will be distributed equally. So no loss, no gain, no charge. You can take the example of H, O, then O, then O, then H like this. Hydrogen having plus one, this hydrogen having plus one. So directly connected oxygen will have, minus one. This can have minus one, but this will have zero. Why zero is here? Because either side both the oxygen atom are identical. So it must have zero oxidation state. Oxygen can go in the plus one and plus two. Before that, we will discuss para superoxide. Let we are having KO2. That is the superoxide. Potassium having plus one. This is having X plus one plus 2X is equal to zero. So now 2X is equal to minus one. So X will be equal to minus one by two. X will be equal to minus one by two. Oxygen can go in the plus one and plus two oxidation state also. There is formation of O2F2. We know that fluorine is more electronegative than oxygen. And remember that fluorine is always having minus one oxidation state. Since fluorine is more electronegative, because both the electron counted in the side of fluorine, here also counted in the side of fluorine. Oxygen will carry plus one here, this oxygen will carry plus one, and the electron present between oxygen and oxygen are going to be equally divided. So that is the region oxygen is going to carry plus one. Mathematically भी बेटा इसको हम निकाल सकते हो 2F2 plus one. How? इसको हमने x मान लिया यहाँ minus one. तो 2x minus 2 is equal to 0. तो 2x is equal to क्या होगा? That is the plus 2. Now x is equal to, that will be plus 1. In this case, what happens when oxygen bonded to two fluorine atom? Both the fluorine is very strong, more electronegative element. Both the electron will be counted towards fluorine only. So fluorine will carry minus 1, this side minus 1, this side they are going to carry plus 2. This is all about it. How to count the electron towards any element. When we talk about the hydrogen, one hydrogen is going to make a bond with the non-metal. The non-metal will carry negative and hydrogen carry positive. But when the hydrogen is going to make a bond with calcium, maybe hydrogen, calcium, we are sure calcium must have plus 2, but we have a doubt about hydrogen. Consider is X. Now plus 2 of calcium plus 2 into X is equal to 0. Now 2X is equal to minus 2. X will be equal to minus 1. In case of metal hydride, hydrogen always have, minus 1. Hydrogen always have minus 1. So let I'm going to do the reaction of O2 plus F2. There is a formation of OF2. Can you think about that? Which element is going in oxidation or reduction? Moving from fluorine to this fluorine and oxygen to oxygen. What is going to happen? Fluorine in combined state always having minus 1, so oxygen is going to have a plus 2. So oxygen is going from 0 to plus 2. So there is a case of oxidation. Fluorine is going from 0 to minus 1. This is the case of reduction. So this is the common, you can think about that, okay, this kind of exception. There is addition of oxygen to fluorine, but there is no oxidation of fluorine. Addition of oxygen is not always oxidation. Similarly, addition of hydrogen is also not always reduction. The electronic definition will be correct. Let calcium is going to react with the hydrogen gas. There is formation of CS2. Calcium having 0. Here we are having plus 2. 0. Here we are having minus 1. Hydrogen is going in minus means decrease in oxidation number. So that is the case of reduction. यहाँ पे हाइड्रोजन का खुद का रिडक्शन हो रहा है and calcium is going under oxidation. Calcium is going under the oxidation. No. Among the halogen, always remember that fluorine is having always minus 1, whereas chlorine, bromine, iodine, they can show minimum minus 1 to maximum plus 7. Minimum minus 1 to plus 7. How to calculate oxidation number of any compound? Let we are having HClF4 आप देख सकते हो यहाँ पे कोई चार्ज नहीं है मैंने. सम ऑफ द ऑक्सीडेशन नंबर ऑफ ऑल द एलिमेंट इज टेकन एज जीरो. तो यहाँ पे बेटा क्या करना है, ऑक्सीडेशन नंबर ऑफ हाइड्रोजन देन क्लोरीन देन ऑक्सीजन. तो 1 into हाइड्रोजन ऑक्सीडेशन स्टेट +1 plus 1 into, let we don't know about the chlorine, we can consider X plus how many oxygen are there? 4 oxygen, each oxygen having -2 is equal to 0 plus 1 plus X -8 is equal to 0. X -7 is equal to 0. X will be equal to +7. And if there is any charge, आपको अगर यहाँ पे कोई भी रेडिकल गिवन है जहाँ पे चार्ज दिया हो, कार्बोनेट आयन में भी सल्फेट आयन. आई एम गोइंग टू टेक द एग्जांपल ऑफ सल्फेट SO4 -2. So we don't know the oxidation state of sulfur, so it consider as X, oxygen -2. Now X plus 4 into -2 is equal to this -2 of this entire charge. X -8 is equal to -2. X will be equal to, that will be equal to +6. X will be equal to +6. And if there is any positive charge, you can also calculate that also. For example, there is a NH4 plus. We have a doubt about the nitrogen. Hydrogen generally having +1. X plus 4 into +1 is equal to +1. X will be equal to -3. This is the general example. You can say sodium maximum is +1, magnesium can go for +2, aluminum can go for +3, silicon having 4 electron valence cell can go for 4, phosphorus can go up to maximum 15, 5, and sulfur is going to +6, and chlorine is going to be 7, +7. Can you think about the element shows highest oxidation state? Yes, it's me. And that is osmium. That is osmium. Got it? Ohms are, it is osmium. They can show up to maximum +8 oxidation state. Now calculate the oxidation state of each carbon atom in C3O2. Let इसका X मान लेना बेटा, इसको X मानना है, इसको X यहाँ -2. This is considered a -2. So now 3X -4 is equal to 0. So now X is equal to +4/3. When we check the oxidation state in terms of bonding, we can check that, terminal -2. So this carbon is having +2. Terminal -2, then this carbon may have +2. And these are carbon atom bonded to either side carbon atom. So this oxygen will have 0. That is also correct. With the C3O2, oxidation state is 4/3. C3O2. Let us talk about the Br3O8. Br3O8. Sorry. Br3O8. So now mathematically we can calculate X, X and X. Now we are having total 3X. How many oxygen? 1, 2, 3, 4, 5, 6, 7, and that is 8. Each oxygen considered at -2 is equal to 0. 3X minus 16 is equal to 0. X will be equal to +16/3. Now check electronically what is possibility. Electronically you can say this is having -2, so this bromine having +2, -2, +2, -2, +2. Entirely bromine is net having, how much? Bromine is having total, you can see here going 2, 3 just -6 and +6. यहाँ पे भी same आना है -2, then -2. So bromine is having +6. In center, -2 from the upper side, -2 from this side, and your total is your +4. So out of this 3 bromine atom, 1, 2, and 3, 2 bromine are in +6. There is a 2 bromine that is in +6, and 1 bromine that is, 1 bromine that is in +4. So this is a going to be average oxidation state is plus 16 by 3, and individual oxidation state is going to be plus 6 and minus plus 4. This is again, you just check that, going to be Br308. This again Br308. Correct, it's all, S4O6. X, X, X and X. The average की बात करेंगे तो 4x plus how many oxygen total? 3 3 just 6. 6 into minus 2 is equal to 0. 4x minus 12 is equal to 0. 4x is equal to plus 12. X is equal to that will be plus 12 divided by 4. और यहाँ पे हमने यहाँ चार्ज को कंसिडर भी देखना था. टोटल इज इक्वल टू नॉट जीरो, दैट इज गोइंग टू बी -2. दैट इज गोइंग टू बी -2. डायग्राम में मिसिंग ये चार्ज यहाँ हिडन है, जस्ट सी दैट यहाँ पे चार्ज गिवन था. दैट इज -2, and that is again equal to -2. And when we rearrange, what will happen? -2 plus 12. -2 plus 12 is going to be 10. Now x will be equal to 10 divided by 4. That is equal to 2.5. What is the final oxidation state of sulfur is 2.5. And if you see that electronically in terms of bonding, terminal sulfur is in plus 6. This is the S. Then triple bond O. 3 2 ja minus 6. Sulfur will be in plus 6. Minus 2 and minus 2. What about this? Sulfur is bonded either side with the same sulfur atom. Both are 0. Terminal sulfur atom again having 3 oxygen. So they have, minus 2 and minus 2. This is having, plus 6. So this is all about individual oxidation state as well as, average oxidation state. Both we have calculated here. SnCl2. Oxidation number, increase in oxidation number is called oxidation, decrease in oxidation number is called reduction. Now we will discuss oxidizing agent as well as reducing agent. Oxidizing agent as well as reducing agent. What do you mean by oxidizing agent and what do you mean by reducing agent? Directly, this is the definition. You can see that, the reagent which undergoes an increase in oxidation state. No, we can, which can increase oxidation number of the element in the substance. The element that help to decrease in oxidation number of any substance. Let's go with the simple definition I will tell you. Let us take the example of, magnesium. Magnesium is going to do the reaction with fluorine. In this case, there is a formation of magnesium fluoride. Got it? Now check carefully what is actually going to happen. Magnesium earlier जहाँ पे था zero oxidation state, right में +2 है, and the year having 0 they are going in -1. Got it? तो there is oxidation किसका हुआ बेटा? Magnesium. And reduction किसका हो रहा है? That is the chlorine. Now let us go in little more detail. Magnesium is equal to magnesium plus 2, plus there is a loss of 2 electron. This is the equation number 1. In this case, magnesium is undergoes in oxidation. Magnesium is undergoes in oxidation. Now what about the fluorine? Fluorine is going to take 2 electron lost by the magnesium to make 2 fluorine fluoride ion. Now see that why the magnesium is going to lose the electron. इस पे थोड़ा सा सोचना है. Fluorine is going to force magnesium, give me electron, give me electron. Got it? The fluorine is responsible for the loss of electron of magnesium. The oxidation of magnesium because of fluorine. The fluorine is known as oxidizing agent. That is the oxidizing agent. When we talk about the magnesium, लेट अस assume अगर मैग्नीशियम ने बेटा ये इलेक्ट्रॉन नहीं दिया होता तो फ्लोरीन कैन नॉट बी रिड्यूस. Magnesium has given this electron, then only fluorine is undergoes in the reduction. The reduction of fluorine is possible only because of electron of magnesium. So magnesium is going to be reducing agent. Magnesium is a metal and metals are generally reducing agent because they have tendency to loss of electron. Reduction of magnesium is because of electron of reduction of fluorine is because of इलेक्ट्रॉन्स ऑफ मैग्नीशियम. तो हम ऐसे एज्यूम करेंगे कि फ्लोरीन का रिडक्शन मैग्नीशियम की वजह से हुआ है और मैग्नीशियम का जो ऑक्सीडेशन हो रहा है दैट इज बिकॉज ऑफ फ्लोरीन. सो दे आर गोइंग टू बी रिस्पॉन्सिबल फॉर देयर these acts. The element which oxidize itself that act as reducing agent, and the element which reduce itself that is called oxidizing agent. Oxidant and reducing agent I have already explained. See that copper is going from +1 to 0. इसका खुद का बेटा क्या हो रहा है रिडक्शन. तो इसका बिहेवियर क्या होगा दैट विल बी ऑक्सीडाइजिंग एजेंट. When we talk about the this oxygen is sulfur is going from -2 to +4. Increase in oxidation number is called oxidation. The behavior of this CO2 S is going to be जिसका ऑक्सीडेशन होगा उसका बिहेवियर क्या करना है दैट इज कॉल्ड रिड्यूसिंग एजेंट रेड एजेंट. So the element which oxidize itself and reduces other is called reducing agent. And the element which reduces itself and oxidizes others that is called oxidizing agent. Common definition we have already discussed this all, summary points. Solve this problem. What the oxidation or reduction occur? MnO4 is going from +7 to +2. So this is a case of reduction. An oxalate and oxidation state of carbon is +3 going in +4. So that is the case of oxidation. That is the case of oxidation. रिडक्टेंट किसको बोलोगे बेटा जिसका ऑक्सीडेशन होगा उसका नाम होगा रिडक्टेंट. ऑक्सिलेट आयन का यहाँ ऑक्सीडेशन हो रहा है तो उसका बिहेवियर क्या होगा दैट विल बी एक्ट एज रिडक्टेंट. व्हिच वन इज द रिडक्टेंट योर ए ऑप्शन ए इज देयर. What will be the oxidation number of chlorine in this two case? HClO4 निकालना बेटा तो HClO4 +1 -2 यहाँ पे x मान लेना. फाइनली +1 + x -8 इज इक्वल टू 0. x will be equal to +7. यहाँ पे भी सेम आने वाला है दैट विल बी +7. After study this much topic you can solve all this question of your chapter. Now let us talk about the type of redox reaction. Your redox reaction can be combination that can be a combination reaction, and decomposition reaction, displacement reaction may be disproportionation reaction. Combination, decomposition, displacement and disproportionation reaction. Combination, let us take the example of combination. Let us take the example of combination. C plus O2 is equal to CO2. Very simple example, see that C plus O2 is equal to CO2. In this case, oxygen is going to chemically combine with the carbon. So this kind of combination, during this combination, we can observe that there is a change in oxidation state. Carbon 0, right hand side +4, oxygen 0, right hand side -2. Overall, it is a kind of oxidation. Here in this case, CH4, burning of methane gas, there is formation of CO2. Combustion reaction is always oxidation. This is also very simple example. Combination of two element is always oxidation. Consider ki there is formation of new compound, not alloys. New compound, not alloys. So this is a very simple example. You can check it. Combination of two element is always oxidation. Again, combination. Decomposition. Decomposition reaction can be oxidation only when there is a change in oxidation state. This is also very important reaction. See that there is change Plus 1 to 0, reduction. Minus 2 to 0 is oxidation. Minus 2 to 0 is oxidation. Got it? Potassium chlorate is a kind of redox reaction or not. Check it. Oxygen is going from minus 2 to 0. It's a kind of oxidation. Chlorine is going from plus 5 to minus 1. It's kind of reduction. But what is the danger point? There is a certain decomposition reaction, but they are not considered to be a redox reaction. It's not universal definition कि मेरे को मान लेना है always decomposition reaction redox reaction. That will be wrong. For example, let I'm having calcium carbonate, and on heating it is going to give us calcium oxide plus carbon dioxide. Left hand side calcium having plus 2, ऑक्सीजन हैविंग -2, एंड इसका आप एक्स एज्यूम कर लो, आपको मिल जाएगा ऑक्सीडेशन स्टेट दैट इज हाउ मच +4. राइट हैंड साइड ऑक्सीजन -2, कैल्शियम इज हैविंग +2. This is having 2 2 -4, and this is having +4. Now compare it. If you compare that, from if you compare this both, what is going to happen? Just check it. Calcium to calcium, left hand side +2, right hand side +2. No change in oxidation state, no redox. Carbon +4, left hand side, right +4. Oxygen -2, -2. What is the conclusion here? No change in oxidation state is non-redox. No change in oxidation state is not a redox reaction. For redox reaction, there must be change in oxidation state. No change. क्या change नहीं हो रहा है बेटा? इनकी oxidation state में कोई change नहीं हो रहा. No change in oxidation state leads to no redox reaction. It's a kind of no redox reaction. Oh, I've given this idea about this. Decomposition reaction is not always redox reaction. Got it? Decomposition reaction can be redox reaction only when there is a change in oxidation state. A displacement reaction is always redox reaction because we are going to displace. There is one. This is the element. There will be a element, and that is going to chemically, combine with a compound. This is a compound. This is a compound. In this case, what will happen? There is a change in oxidation state of the element so that it is going to be redox reaction. Maybe from metal to metal or maybe from non-metal to non-metal. Let us take the example of zinc and copper sulfate. Zinc is having 0, right hand side having +2. It's a kind of a case of oxidation. See about the copper is going from +2 to right hand side 0. So that is the example of reduction. Displacement reaction of metal to metal, maybe non-metal to non-metal. Metal displacement can be, नॉन मेटल डिस्प्लेसमेंट भी हम आपको दिखा सकते हैं. नॉन मेटल रिएक्टिविटी ऑफ मेटल यहाँ पे आप देख सकते हो. नॉन मेटल में लेट बी आर हैविंग sodium iodide going to react with the sodium fluorine gas. Fluorine is more electronegative than iodine. Then what will happen? There is a formation of sodium fluoride and there is loss of iodine. So this is a case of finally non-metal displacement. Fluorine is going to displace iodine because fluorine is more reactive than iodine. So that is a kind of again redox reaction. Displacement of hydrogen is also redox reaction. These are the example non-metal displacement. But make cadmium cannot displace water. Okay, it's not. We knows already. KCl plus F2. So this is also very important factor. Displacement reaction we never try to carry it out with the help of fluorine in aqueous medium because chlorine is more reactive than oxygen. So that is going to liberate oxygen gas. Chlorine is more reactive than oxygen. So that will be happen, there is a formation of oxygen gas. Chlorine can displace out of this fluorine, chlorine, bromine, iodine. We should know fluorine is more reactive than chlorine, then bromine, then iodine. This reactivity, we can remember it for the non-metals. What do you mean by disproportionation reaction? Left hand side, this oxygen is having in -1, right hand side, this is having -2 and 0. On the same element undergoes in oxidation as well as in reduction. So there is a oxidation as well as reduction. Same element undergoes in oxidation as well as reduction. Then it is said to be disproportionation reaction. When same element undergoes in two variable oxidation state, then also it is a kind of disproportionation reaction. Disproportionation reaction. For you can take example of this white phosphorus and then basic medium. Phosphorus is moving from 0 to -3 and right hand side it is having +1. Moving from 0 to -3 is reduction. Moving from 0 to this +1 is kind of oxidation. तो whenever आपको जब भी ये सिचुएशन मिलती है दैट इज द केस ऑफ disproportionation reaction. When same element undergoes into or more than two variable oxidation state, that is called disproportionation reaction. Now you can identify there is a disproportionation reaction or not. Carbon is having -4, hydrogen having +1, 0, -2, +4, -2 and +1. So now oxidation state, it is not a disproportionation because same element is not going in two different oxidation state. So this is not a redox. This is not the case of disproportionation reaction is going to be this NO2. I hope this is going to be NO2 having यहाँ पे +5 आएगा. नाइट्रेट -1, इसका ऑक्सीडेशन से डाउट है. आप -x मान लो. यहाँ पे कितना होगा बेटा? -2. x -6 इज इक्वल टू -1, तो x विल बी इक्वल टू +5. और इन केस ऑफ NO2 -1, oxidation state of N is how much? X plus 2 into -2 is equal to -1. X will be equal to +3. On left hand side, nitrogen having +4. It is moving from +4 to +3 and +5. So this is a case of disproportionation reaction.